In this lecture, we are going to learn about the Renin-Angiotensin-Aldosterone System. This is the system in our body that is activated when there is the low blood pressure and obviously low blood volume. So to maintain the blood pressure and the blood volume, this system is activated. So the chief regulator is our kidney. Kidney is the chief regulator of this system, and it comprises of cortex and medulla. So the kidney is made up of millions of the nephron, that is also known as the functional unit of the kidney, and the majority of the nephron lies in the cortex of the kidney, and the some part like majority part of the nephron lies in the cortex of the kidney, while the some part lies in the medulla like loop of Henle and the collecting duct. And this one is the nephron with the different parts. Nephron of the kidney with the different parts. So the blood comes in from the efferent arterioles, and the glomerulus, which is between the efferent and efferent arteriole, filter the blood, and the filtrate comes from the tube, proximal convoluted tubule, loop of Henle, distal convoluted tubule to the collecting duct, then excreted from our body. But the filtered blood pass out from efferent arteriole. That is the mechanism how the filtration system is there in the kidney. And as the nephron filter 125 milliliter per minute. So the total amount of the blood that is filtered by our kidney is 180 liter per day. But they all are not excreted from our body. Only about approximately 2 liters of the filtrate is only excreted from our body, and the rest are backed up in our body. And there are different cause of low blood pressure and low blood volume. Like the low blood pressure can be there due to the dehydration, or due to the blood loss, due to shock or trauma, and in the severe infection also, and also in the lack of nutrition, and so on. There may be the different causes. And how it works to maintain the blood pressure. First of all, we have to know about the renin. The renin is secreted by juxtaglomerular cell, which is present in the efferent arteriole, like this, which are present in the efferent arteriole, that releases renin. And how is it stimulated? Like when there is low blood pressure, then the juxtaglomerular cell of the efferent arteriole become stimulated and they release the renin, because these cells are baroreceptor, so that they can sense the pressure of the blood in the efferent arteriole. And also, as we know that the proximal convoluted, when the filtrate pass out through this tube, then some of the filtrate particle are reabsorbed in our body. Like the proximal convoluted tubule, sodium is reabsorbed approximately 65%, and in descending loop of Henle 15%, and ascending loop of Henle 15%. Likewise, the remaining of the filtrate, remaining of the sodium that is reabsorbed is 5% in the distal convoluted tubule. Now we knew the reason why the renin is released, and the reason is when there is a low blood pressure in the efferent arteriole, then the filtrate also is low, so that the blood pressure and so that the filtrate volume is also low. So there is the maximum time for the sodium to reabsorb from the proximal convoluted tubule, loop of Henle, and distal convoluted tubule. Likewise, when the filtrate goes out to the distal convoluted tubule, then there is the less sodium in them. So due to low velocity of the filtrate, then they got more time to reabsorb the sodium, so that it triggers the efferent arteriole when there is more time to reabsorb the sodium, and when there is the less sodium in the distal convoluted tubule, then the efferent arteriole is triggered by the macula densa cell that resides in the distal convoluted tubule. Macula densa cell. So that when there is a low amount of the sodium in the distal convoluted tubule, then the macula densa cell is triggered, so that it finally stimulates the efferent arteriole, juxtaglomerular cell of the efferent arteriole, then it releases the renin, likewise discussed before. So that is about the renin. So the renin is already released in the systemic circulation. Now let's come to the angiotensin. Then the angiotensin is the protein that is in the inactive form in our liver, and its inactive form is angio, that means blood vessel, and tensin means pressure, and tensinogen, ozen means the inactive form that is present in a liver. So the liver also releases the angiotensinogen in the systemic circulation. So when the angiotensinogen that is inactive meets the renin released before, so it is converted into the angiotensin, that is the active form. This one, the active form. So the angiotensin is angiotensin, that is the active form. Then the angiotensin that is also known as the angiotensin 1. There is the angiotensin 1 and angiotensin 2. So first of all, there is the release of the angiotensin 1 after the conversion of the angiotensinogen from the renin. Then the lungs also play the role in this system. They produce angiotensin converting enzyme. Angiotensin converting enzyme. So by the name we can know that the angiotensin 1 is going to be converted into some form. So when the angiotensin 1 that is produced after the activation of the angiotensinogen, then that is stimulated by the angiotensinogen converting enzyme to angiotensin 2. So that is the more angiotensin 2 is more important in this system, because they have the major role in controlling the blood pressure and making the blood volume high. So let's come to angiotensin 2 enzyme. So first of all, now the angiotensin 2 is made, so that they play the role in vasoconstriction, due to which the blood pressure increases due to the constriction of the blood vessel, and also they constrict efferent arteriole. So how the constriction of the efferent arteriole makes up the blood pressure high? Like when there is a constriction of the efferent arteriole, then the blood back up into the glomerulus. Then there is the high amount of the blood in the glomerulus, and the filtrate is also high, so that it maintains the absorption of the sodium, and also does not trigger the renin to release. So it maintains the blood pressure. And likewise, it also stimulates aldosterone release. aldosterone is released by the adrenal gland that resides at the top of the kidney. Like we have two kidneys, and at the top of the kidneys there is the adrenal gland, and from adrenal gland the aldosterone is released. That is the adrenal gland in the top of the kidney, and when the aldosterone is released, then that major function is to reabsorb the sodium, reabsorbs the sodium from the distal convoluted tubule. The amount of the sodium from the distal convoluted tubule is reabsorbed in the circulation, so that the water comes along with the sodium. We have to know that the path of the water is decided by the path of the sodium also. So when the sodium is reabsorbed, the water along with the water is also reabsorbed from the sodium, and obviously the blood volume rises in the systemic circulation, as well as the blood pressure also rises. And lastly, it also stimulates ADH secretion, antidiuretic hormone, that is secreted by the posterior pituitary gland. So it is also known as the vasopressin. So that the more water is reabsorbed from the collecting duct and distal convoluted tubule. By the name we can know that the antidiuretic hormone. So it reabsorbs the water from the collecting duct and the distal convoluted tubule, due to which the blood volume rises, and obviously there is a rise in the blood pressure. That is all about the renin-angiotensin system, so that we can know how it works in our body. Thank you.